All right, so if we turn to the data, it's from HistPath and the US Patent Office, and it was provided by my TA Chris, as I said. And it consists of 161 yearly values between 1850 and 2010 with no missing values. And clearly it's quite, it grows a lot, so it was quite difficult to make stationary. Um, for example, I fitted this cubic model that looks pretty good, but when you look at the residuals plotted at the right, you see that they're not homoscedastic, which doesn't fulfill our requirements. So after talking to Rick, I took the log instead, which you can see on the left, and I fitted a cube root model. And the residuals that I fitted on the right at least look believably stationary, even though there is a lot of smoothness still, which we're going to address. So carrying on to model fitting and prediction, I started by plotting the ACF and PACF for the detrended data. And as we can see in the autocorrelation function, or the plot of it, is that there's a lot of smoothness remains, and especially at really high lags, which is kind of problematic. But we're not going to look at those lags probably. There's also potential signs of seasonality in the PACF that cuts off pretty fast, but then, for example, lags 6, 10, and 11 are all significant. So this tells us that this might be a lower order AR or perhaps a Serima model. And after trying a bunch of different models, I picked up one seasonal and one non-seasonal. That you can see here. And if we just dive into the coefficients a little bit, I think it's interesting that in the seasonal one, we have a negative 5 lag 5 coefficient and a positive lag 6 coefficient. And in the non-seasonal, the AR3 is negative as well as the AR5. So both of these things tell us that there might be a 6-year and a 10-year cycle going on potentially. And we'll see more of that. And here are the residual sort of analysis of the both of the models, and they look pretty decent. If you look at the standardized residuals, there are only a few that are more than 2 standard deviations away from 0, which seems to be the mean. Both the ACF and the QQ plots look pretty good for both models. I think the only problem is the young box statistics, where especially for the non-seasonal model, actually a few of them are significantly sort of far away from white noise, which might be problematic. But overall, it looks like it's kind of pretty much white noise, but with some dependencies still there. And if we carry on to use these models for prediction, we see that they give very different predictions for the future. This is from the end of the data set and 20 years into the future. And the non-seasonal models predicts that the growth is going to continue, but at a slightly lower rate, which I find kind of believable. Whereas the non-seasonal model predicts that it's going to return to the values around 2000 and sort of playing out there. And to test these models on more data that we can actually look what the real values were. I trained it for up to 1980, and then had them predict for the last 30 years. And both of them are pretty far off. None of them could predict this explosion of patent output in Boston. And the seasonal model does a decent job for the first 12 or so years, but then just trails off. And the non-seasonal model is never really close. However, if you look at just the last 10 years, it's actually the non-seasonal model that's doing a better job. And the seasonal kind of predicts it going down again, so to speak. So in general, the predictions don't seem that convincing, at least to me. But they're not completely off in shorter periods, at least. We carry on with some spectral analysis to see if we can learn anything more about these models. And first we look at just the detrended data, not the residuals. And the periodogram that's moved to the left here indicates periods of, like cycles with periods of 10 years and 3 years. I also tried some parametric estimation, but it didn't work. But yeah, these indications seems to be in line with what we've seen before. I also looked at the spectral analysis of the residuals, and periodograms were really hard to read. So I tried parametric estimation, and they both show that there's clearly some dependency left in the residuals of both models. I find it hard to interpret, but there seems to be some dependency left, although the absolute values in these spectrums are pretty low, which is worth noting compared to the other ones. So a lot of the variance has been removed by the models, which is good. So the final conclusions are that there are strong indications of cyclic behavior. The period seems to be 6 years and 10 years, but perhaps this could be, that's at least what I believe, but perhaps this could be a mix-up and it's somewhere in between, but they seem to be different cycles going on. The predictive power is pretty unimpressive in my view, but if we're going to learn anything from them, it seems that the growth might slow down after 2010, which I haven't been able to verify. But that's what the models are telling us about the future. But we've also seen that they were wrong, or not at least spot on for earlier periods. And there's so many ways in which we could improve the models. For example, better detrending. As we saw, the detrended data was still kind of smooth, so we might want to find a better detrending somehow. We could also use data from more cities to train the models if we're interested in cities in general and not Boston specifically. And perhaps we could introduce some explaining variables such as R&D spending, both private and public, population growth, and stuff like that. And yeah, that's about all I had to say. Thanks.